Hello class, it's Mr. ARocena, and today we are going to be talking about redox reactions. So this will just be a quick introduction to what redox reactions are. Let's see. There we go. Alright, so redox stands for, it's kind of a combination of the two words oxidation and reduction. So reduction and oxidation reactions are reactions that occur all throughout chemistry. They're most known or most useful when talking about electrochemistry because the reactions deal with the movement of electrons. But to be quite honest, all forms of chemistry require the movement of electrons in some fashion. So oxidation reduction reactions are actually a little more common than what we would suggest in Chem12. If you think back to previous science classes, previous chemistry classes, you'll actually probably realize that the movement of electrons is quite important in a lot of chemical reactions. Whether we mentioned it explicitly or not, though, that's a whole other matter. All right, so a reduction is simply the reaction that so the reaction where electrons are gained. So during a reduction reaction, one of the substances or several of the substances in the reaction gain electrons. So this is half of the reaction that occurs in an electrochemical cell. So electrons are lost by one substance, another substance gains them. So the substance that gains undergoes what's known as a reduction reaction. Okay, so these are gained by a substance. Yeah. Now oxidation, remember reduction reactions are always followed by an oxidation reaction or accompanied by an oxidation reaction. You can probably guess an oxidation reaction is the opposite of that. So an oxidation reaction is when electrons are given up. So a reduction reaction is a reaction where electrons are gained, but in order to gain those electrons, something needs to lose the electrons. So that's what oxidation is. Oxidation is when electrons are lost by a substance. So in a lot of chemical reactions, actually all chemical reactions, some substance will give up electrons and some substance will gain electrons. This is it's easy to observe in an electrochemical cell. So in every electrochemical cell that is created, one substance undergoes a reduction reaction where it gains electrons, and one substance undergoes an oxidation reaction where it loses electrons. Now, this was asked earlier in class today. They predicted that the oxidation reaction results in a gain of oxygen, and that's often the case. Often, but not always. So if a substance gains an oxygen atom or an oxygen ion during the reaction, we often call it oxidized, but the oxidization is actually a result of the electrons getting lost, and then that substance will then have a positive charge which will allow oxygen ions to move towards it. Okay, so take for example iron oxide, or I guess iron 2 oxide. No, iron 3 oxide. This is rust, and this is the oxidized iron. Okay. So when iron gives up electrons, it has the ability to absorb oxygen ions. Now this is usually, the source of the oxygen ions is usually water. So that's why when iron gets wet, it has the ability to give up electrons, and then because there's an abundant source of oxygen in the water, the iron can absorb that. Because it now has a bunch of positive charges, the iron can absorb the excess oxygen ions that may be present in the water and form this substance here. So oftentimes oxidation is a gain of oxygen, but keep in mind, not always. There are a lot of reactions where a substance will get oxidized, meaning it gives up electrons, but it doesn't gain oxygen. So this is a definition that we will use for oxidation. Even though, again, quite often oxygen ions or oxygen atoms are gained by the substance undergoing oxidation, it's not always the case. Okay. So in an electrochemical cell, this is quite common. So, for example, a very simple electrochemical cell looks like this. We basically have a citrus fruit. You might have done this in elementary class or something like that. Citrus fruit, and then we jab two metals, usually copper and zinc. Okay. And what will happen here is the acid in the citrus fruit will slowly force the copper to turn into copper ions, okay, and then also turn the zinc into zinc ions. Now what happens here is that when this occurs, this chemical reaction will then allow kind of two things to happen. The copper ions have the ability to absorb electrons, and this will turn them into solid copper pieces. And the zinc ions can kind of do the same thing. The zinc ions have the ability to absorb electrons and turn into zinc. We'll make these equilibriums. Okay, but the reverse can also happen, where we get the solid copper turning into copper ions and electrons, and the solid zinc turning into zinc ions and, whoops, that's strange. Let's erase there. Okay. And two electrons. Oops. So these are possible things that could happen. Now it turns out that the reactions that do occur due to the nature of these substances is this. So this reaction will occur. The zinc has the greater ability to give away its electrons, so it will do this more often. And copper has a greater ability to absorb electrons, so this will be the reaction that occurs. Now, without any kind of path for the electrons to travel in, what will end up happening is the zinc, as it's turning into ions, will start to build up a bunch of electrons on it. And the copper will slowly disintegrate into copper 2+ ions, unless it starts absorbing some of these electrons. So what we can do is we can attach a wire from the zinc to the copper, and the electrons can then flow this way. So what this means then is that as the zinc undergoes its oxidation reaction, it's building up, giving away electrons, and we can give those electrons a path to get to a substance that really wants the electrons. And this is what is effectively a very simple battery. Okay, and that's one of the things we've learned with redox reactions, is that we can create these simple batteries, and we can create electricity this way. And if you put something like a light bulb, it might be enough to light a light bulb up there, or a motor or a clock or something like that. Okay. Now, in every, like I mentioned, in every redox reaction, one substance undergoes reduction, one substance undergoes oxidation. And it was asked earlier in class, how do we know which is which? Well, we'll talk about we classify the substances into oxidizing and reducing agents. Okay. So oxidizing agents, I think I'll talk about reducing it. No, oxidizing agents first. Okay, so oxidizing agents cause substances to be oxidized. Okay, so these substances don't actually get oxidized, they cause other things to be oxidized. So an oxidizing agent promotes or makes other substances lose electrons. Now, because of that, the oxidizing agents will tend to gain the electrons that they've just forced away from the other substance. Okay, so keep this in mind. So oxidizing agents are reduced. Okay, it's very common to think oxidizing agents get oxidized because that's kind of what the intuitive nature is, but that's not why we call them oxidizing agents. We call them oxidizing agents because they make other things, so other substances oxidized. So other substances get oxidized. Right. Now, reducing agents do the opposite. So if an oxidizing agent causes other things to be oxidized, a reducing agent will cause other things to be reduced. Okay. Because if something is forcing something to give up electrons, and something else is forcing things to absorb or take electrons. Okay, so a reducing agent causes other things to be reduced. A reducing agent basically forces electrons onto something else. Okay, as a result of a reducing agent giving away its electrons, reducing agents end up getting oxidized. So a reducing agent gets oxidized. Okay, so sort of recap, oxidizing agents force other things to oxidize. Or to undergo oxidation. Okay. And then reducing agents force other things to get reduced. Okay. So going back to our zinc example, the predominant reaction is the zinc turning into zinc ions and electrons. Okay, so this is the predominant reaction that gives away electrons. So in this case, therefore, zinc is a reducing agent. The copper, on the other hand, or copper 2 ions, the copper 2 ions tend to absorb electrons to become copper solid. So therefore, the copper 2 plus is the oxidizing agent. Oops. There we go. Yeah. So zinc is the reducing agent because it's the one that is forcibly giving up its electrons, and the copper 2 plus is the oxidizing agent because that's where the electrons go. If I go back to my cell, where the electrons are flowing this way, when the electrons get to the copper, it's not the solid copper that's absorbing the electrons, it's the copper ions that were forced into the citrus fruit that are absorbing the electrons and then becoming solid copper on the piece of copper that you've stuck in it. Okay, so the copper 2 plus ions, those are the oxidizing agents because they're the ones absorbing the electrons and getting reduced. Okay. Right, so here's another example, just in identifying what's the oxidizing and reducing agent. So this is another battery basically, and it's made out of magnesium and zinc, or zinc 2 plus ions. Okay, now when I look at this, which of these substances is getting reduced? Which one of them is getting oxidized? And you can basically ask yourself the following, okay, does this gain or lose electrons? Does this gain electrons or lose electrons? Okay, and then you can ask the same thing about this one. Okay, and you can sort of think about, okay, my magnesium is going to magnesium 2 plus. So here it's gaining a charge of 2 plus. Now, if you remember your early chemistry, if something becomes more positive, it means it loses 2 electrons. So you immediately can say, okay, so the magnesium is losing 2 electrons to become magnesium 2 plus. So magnesium is the reducing agent because it's getting oxidized. Okay, and that means then that the zinc 2 plus is the oxidizing agent because it has to be. There's no other way, at least in this example. If I have my reducing agent, I then automatically know what my oxidizing agent is. And you can think of it oops, let me erase a little bit here. You can sort of think of it like this. You have two reactions, and the first of which is this one, where the magnesium loses its electrons. So you have magnesium going to magnesium 2 plus and creating 2 electrons. The other reaction is the zinc 2 plus gaining those electrons and becoming zinc. That's the other reaction. So this is the reducing agent reaction, reducing agent getting oxidized, and this reaction is the oxidizing agent getting reduced. Go. Okay, so there you go. So every chemical reaction, not just electrochemical reaction, every chemical reaction will have one reaction or one substance getting reduced and one substance getting oxidized. And all it really means is that substance gains electrons and one substance loses electrons. And when you think about it, this kind of makes sense, because in every chemical reaction you've done up to this point in chemistry, something has to lose electrons to combine with something else, which is gaining those electrons. Okay. We just never called them oxidation or reduction reactions. We just said one substance is giving electrons to another, or one substance is sharing an electron with another, or something like that, right? All right. All right, now here's a mnemonic to help you remember each of the reactions that we just talked about. The first one's my favorite. Leo the Lion says Gur, and that stands for the following. So Leo stands for loss of electrons is oxidation, and Gur stands for gain of electrons is reduction. And the other one, given to me by my chemistry teacher, is oil rig. Oxidation is loss of electrons, and reduction is gain of electrons. Okay. So with this in mind, you should be able to hopefully have some way of remembering what an oxidation reaction is and what a reduction reaction is. And from that, understand that oxidizing agents cause things to get oxidized and reducing agents cause things to get reduced. All right. So anyway, so that's the that's the first introduction to redox reactions. We will get to the last table in your data booklet. I think tomorrow. Yes, we'll discuss that tomorrow, because there are a lot of information with regards to oxidizing agents and reducing agents. Okay, and not every substance is equally reducing agent or equally oxidizing agent. As I mentioned earlier with the zinc copper fruit battery, the zinc naturally has a tendency to give away electrons, whereas the copper has the copper ion has a natural tendency to absorb those electrons. And that's just the nature of the product. Anyways, we'll discuss more of that in the next lesson. Okay, if you have your textbooks, your assignment then will be as follows.